to bring the emu service to the desired capacity of 2 running workers. And now, in addition, we see the ECS target. So this is for emu itself, and then an app auto-scaling policy. So it's not the same API as the EC2 auto-scaling functionality, but similar in concept, and it works for ECS. So if we step back here, once these workers come up, and indeed there's the emu workers that are up and healthy now, there is an auto-scaling policy attached to this ECS service, which we can find in here under configuration. And if you scroll down, then you see that there is a CPU utilization policy attached, and it's tracking the ECS service average CPU utilization at 25%. These are things that kind of, the way that we think of them are, these are knobs that we expose so that end users of the reference architecture can tune them. You might not agree with the value of 25% for your average CPU utilization across the service. That's the value I've found to be useful as a watermark to signal to emu that there's a ton of work on the queue and we need to spin up additional workers. So this works well to say when Pelican loads the queue with a ton of messages, then this emu worker alarm for the auto scaling policy goes into an alarm state and spins up an additional 25 or 30 or 40 emu workers, and then they immediately start chewing through the queue very quickly. There's other ways to do it as well. You might also prefer a policy, which we might do in a follow-up or demonstrate somewhere else, where you can actually read and calculate the exact backlog from the queue that each individual ECS worker would have. There's just different ways of doing it. Pelican actually also has a policy attached to it, and then we can see that now that this came up, there's one alarm that is in OK state, meaning that it's not triggering, and then the other one is insufficient data. But once it reaches enough data points to signal that it is in alarm, it will switch to alarm, and then we'll see automatic scale in or scale out behavior in ECS to bring this worker count for the emu service to a higher number, anywhere up to 40 or 50, which is where it's currently set as the maximum capacity in code. While we're waiting, I will also mention or show, if we look in the code here, where is this actually defined? So if you scroll to the bottom of the file, here's one. You can see this is the ECS front-end service configuration that includes the container arguments and everything. So CPU and memory are relatively lower for this one because it's not doing a ton of work. However, if we scroll down here, we see the Pelican service itself a little bit beefier, and same for emu. The emu is really doing the lion's share of the work, and so it has the most resources. But if we come here, ECS target is what defines the auto-scaling behavior for the emu workers. So we're saying that this is constraining our emu workers so that we don't want any more than 50 of them running at once. We want a min capacity of 2. That's why there's 2 that are currently running when we look in the AWS account. You may desire to increase this to 150, 250, etc. if you're doing high-scale processing. The thing to be aware of is that most AWS accounts by default to start with are going to have a lower quota for what's called vCPU, virtual CPUs, that you're allowed to run simultaneously via ECS Fargate. So if you desire to run more than 50 emu workers or additional Pelican workers, or you have a very high scale use case, one of the first things you're going to want to do is to put in a quota increase request in your AWS account for the number of vCPU units that you're allowed to run concurrently in ECS Fargate. So that's just an important note for folks with high scale use cases, but essentially this is the CPU utilization policy for emu, and that's where we set the target value of 25. And that's, again, intentionally to kind of keep it not artificially low, but low enough so that it meaningfully trips as soon as there's enough work on the queue and quickly spins up, additional emu workers to actually chew through the queue results quickly. You can also tweak scaleInCooldown, scaleOutCooldown, which is how quickly after a scale out or scale in event can the auto scaling service attempt another scale out event. So for example, keeping this value low in cases where you have lots of work on the queue will help the auto scaling service get your workers to the higher limit faster. And that's part of why I have it configured this way here. But the nice thing is that because the entire architecture is defined as code, anybody that's deployed it can come in here, tweak this value, run Pulumi up, and you will get the modified behavior that you're looking for. So that can be pretty handy. It's also important to note that in addition to the EMU auto scaling configuration, we actually have similar auto scaling behavior for Pelican, although you'll notice that the values are different. So because Pelican is selecting records out of Postgres or listening for records that have changed out of Postgres and placing them on the queue, it's not dealing with the same compute intensive processing that EMU is when it's converting everything to embeddings and upserting things via API call. So just note that the Pelican autoscaling policies are tuned slightly differently, but because it's all code, you can come in here and modify it to your heart's content. All right, and if you blinked, you missed it, but the deployment is complete, and this actually went a little bit quicker than usual, so 14 minutes and 35 seconds. Let me quickly move myself out of the way here so you can see this. So the entire deployment end-to-end took 14 minutes, 35 seconds, and now let's quickly step through and look into the account and see what's running there. So now you'll notice that the ECS clusters are all up, each has one service, and there are 2 workers running. And again, this is desired by default. There's not a lot of work to be done, at least initially when the system wakes up. So, and also at steady state, we want less workers in order to keep our costs down. But if we add a ton of work to the queue, or if the data bootstrapping initialization process is happening, which I'll talk about in a quick follow-up video, then we want these to auto scale out. And so just as I showed with the EMU worker and service, the Pelican service also has configuration here, and it has an auto scaling policy that will scale it up and down as well. And if we go to RDS now, we'll see our central RDS database is running here. And that's up and healthy. We can see that it's not under significant load. There are connections because Pelican is connected directly to it. And so that is our RDS database. Let's also quickly just sanity check that in our front-end ECS service, because the front-end service is a little bit different. It's running in the public subnets, and it also, the service has associated a load balancer, and we can open up the load balancer directly, and boom, we get the UI and the app experience. And we get back the sample products, and then we can start doing semantic search in here. All right, so it looks like a healthy deployment in 14.5 minutes. Also, the other major piece to look at is our queuing. So if we go to SQS, here's where we'll now find our 2 queues. The first queue is the dead letter queue, and so that's going to be for any messages that couldn't be processed initially. If these were to be, the fact that these messages on the job queue are in flight means that they're being read off by EMU, and EMU is working. These messages were placed here by Pelican, but if any were mishandled or couldn't be addressed correctly due to errors, they would go to the dead letter queue. And the dead letter queue has an associated SNS topic that allows you to subscribe to it either via email or text, so that if you needed to, you could get updates saying that a critical job had failed to process. But that is it for this initial video, just to demonstrate how to deploy. Hope you enjoyed it, and then stay tuned for some follow-up videos where next I'm going to talk through how to launch a jump host in order to interact directly with the resources running in the private subnet, such as the RDS instance and or the microservices if you wanted to. And then I'll talk more about the architecture and the functionality of the system and how the data flows in another follow-up video. Thanks for watching.